everything, if I'm related to it, then it's Phil's goat. So that means we're going to give it a new letter. We're going to call it D because we already used C. Technically it's in a separate block. We could reuse the letter, but that's confusing. So if I'm related to Derek, then Derek is Phil's goat. Oops, we've already done 8, we're up to 15. So from 15, a universal introduction. That RAD is RAD with brackets. Now that's an arrow, which means we're going to assume that's 16. I'm related to Derek. Then we will show that Derek is Phil's goat. This is our arrow introduction rule. 16 to 17 by arrow introduction. Now that's an identity. We prove an identity using identity introduction. And that will be from our block 18. I don't know how big that block is, so I'm going to guess it's about half the page. So 18. I've got Derek, and I want to show that Derek is Bill's goat. I've got some space here for working, so I can use this or anything else I might happen to have. Now, how do I do this? Well, I want to be making use of this at some point, so this might give me some sort of clue. I've got RAD, and I want to be able to use this thing here to get this. Why? Well, they wouldn't have given it to me unless it was useful, so I'm really hoping it's useful. So f of b is a, that's a rule, that's line 1. So I'm going to change a to f of b. Uh, 19. Just in case it goes up here so I can get something that might be useful. It's all very speculative. So that comes from 16 and then 1. Because 1 says that a is equal to f of b. So now I'm going to try to substitute this in here to see what happens. This x becomes a d. So r of fb comma d implies d equals g of a. That's from 6, universal elimination. And I chose that particularly so that these two would go together. So let's use those. 21, we have D, Derek is Andrew's goat. From 19 and 20, an arrow elimination. That's good because we were stuck before on what to do with this. So this is D is GA by 21. Now what to do with G of A? Well, the only thing we know is that G of A is equal to D. We could change it back to D, but we've already done that. That's not going to help much. You also know that A is equal to F of B. So let's change that. G of A becomes F of B by 1. And now we can use line 2, which I'll just go over and show. 2 says that G of F of B is equal to G of B. The G of F of B, which is this here, becomes GB. So by 2 and a little bit of luck, and trust me, it wasn't a bit of luck, I was making it up as I went, we have shown that Derek is Bill's goat under these assumptions. So anything related to me implies that Derek is, so Derek's related to me, then Derek is Bill's goat. Anything related to me means that thing is Bill's goat. So that's the end of the second half of the if and only if. So we've proved if this, then that, and if that, then this. So this, if and only if that. Why we would want to prove this, I don't know. Why I'm related to someone's goat, I don't know. But it's logic, so it is true. You can see we've had to use normal identities plus using an arrow to get the right two identities to match up, bit of problem solving to fill it in. We had to do it twice because it was an if and only if. This is the sort of proof that would be probably the hardest proof that we would do in terms of exam size. Maybe something slightly smaller than that. That was what, 21 lines? Unless I missed a line, counted it twice. We used a couple of identities, a couple of substitutions with plans. Nothing hugely weird, but we had to think ahead a few moves at times.